In this question 5, you are given an algorithm to determine if an input array A has an arrangement that is palindromic. The algorithm first counts the number of occurrences of each element in the array. And if all the counts are even, or exactly one of the counts is odd, it will return true. Otherwise, it will return false. This algorithm is big O of n squared in complexity due to this part of the algorithm, whereby counting the number of occurrences of each element requires it to go through the array a number of times in order to count each element. You are to come up with an algorithm that does the same task but with a better time complexity than big O of n squared. Well, one solution is to sort the input array first. Once the array is sorted, all the same elements will be grouped next to each other. And you will be able to count the number of occurrences of each element by scanning through the array just once. So, for example, if this is the array, all right, and you can see that the elements are not sorted, and in order to find out the counts of each element, you will have to scan through the array a few times. So the first time, probably you just count the number of occurrences of B. And then the second time, you will count the number of occurrences of C. And then the third time, you will count the number of occurrences of A. And in the worst case, you will have to scan through this array n times to count the n elements in the array. However, if you sort this array, all right, so for example, this same array, I sort it, okay, you will see that all the same elements will be grouped next to each other. Now, once they are grouped next to each other, you can actually just scan through the array to count each of them. So for example, I can scan through to count the number of occurrences of A. And once I hit a different number, I will quickly save up the count for A. And then I will reset the count of the second element, the second different element to a new count, whereby I will start counting from there. And when I hit another different element, I will save up this current count again and then reset the counter back to 1 and then start counting from there until I hit the end of the list. And you just need to go through this array once. Okay, so this gives rise to our first algorithm. So this first algorithm here, all right, the first approach is to sort the array first. And the time complexity will be big O of n log n. All right, this n log n basically comes from the sorting part. Okay, because sorting the array, whether you are using the merge sort or whether you are using the Python sort, it will still take n log n. So step number 1, you sort the array. Now you can just directly call the merge sort m sort, or you can call just sort like the Python sort. Now you are not required to provide the sorting algorithm because this part we assume that you already know how to do it. Now, then come to step number 2. Well, here I have a count array to keep track of the counts of each element, each distinct element. And I'm going to start counting. So I set the current element to be the first element and count to be 1 because this current element, I'm going to start counting it. So it is going to be 1. Now then, I will scan through the array. For each of the subsequent elements, all right, for each next element, if it is the same as the current element, I will just increment the counter. Okay, increment the count. And this will go on until you hit the next element, which is different. Now, once you hit the next element that is different, Well, I will append this current count that I have computed, all right, which gives me the count of the first element. I will just save it to this count array, all right. Then I will reset the current element to be this new element, this new next element that I have just encountered, and reset the count to 1. All right, basically this new element is going to be count as 1. And here it says repeat step 3, basically repeat this step until there is no next element. So you can see that this is how you can accumulate the counts and slowly store up the counts into this count array. So by the end, when you finished looping through and check through all the elements, all you need to do is to go through this count array, to check how many entries are odd entries. Okay, so I save it into an odd count. Now, if this odd count is less than or equals to 1, which means that there is either 0 or 1 odd entries only, then it means that this input array has an arrangement that is palindromic. So I can return true. Otherwise, I will return false. Okay, so you take note that the sorting part is n log n, all right? This is constant time. And this part, basically, you just need to scan through the array once. So it's on, all right, big O of n. And this part is also big O of n. And this part is just constant time. So when you sum it up, you will see that the dominant terms come from the sorting part. That is why it's big O of n log n. Now, for this algorithm, there are actually a number of ways to do it. Some of you don't actually keep track of this count array. Instead, you directly have the odd count here. And as you are counting, each time you finish counting one group of elements that are the same, you directly check whether the count is odd or even. All right. If it is odd, then you increment that odd count. And at any point in time, if your odd count is greater than 1, you directly return false. Okay. And if you finish this loop, you don't get to return false. Directly, you come to the last part. At the end of the loop, you just return true. Now, that is also a good way of doing this algorithm. So here is the Python code for doing this part. You can actually see how the two while loops, all right, are being used to control such that you can scan through the array just once to count the number of occurrences of each element. Although it's a nested loop, it looks as if it's n squared, but actually this loop just goes through the array once. Okay, you can see that over here, all right, my I, although I start from 0, but each time it is reset to j, okay, to continue from the next different element. So I is always set to the index of the first element that is different from the previous element. Now, another approach is to use the dictionary, which quite a number of you actually use this approach. All right. And the time complexity is even better. You can hit big O of n. So at the start of this algorithm, you can just create a dictionary. All right. And you just need to go through the array, the input array once, and start to build up your dictionary this way. If the elements in the array already exist as the key in your dictionary, all right, all you need to do is to just increase the counter. Okay, so increase the value of that particular key. Now, if it is not in the dictionary, then you just create one entry for it and set it to be 1. So after this once, you will build up the dictionary. So for example, if this is your array, all right, after this loop, you will build up this dictionary, okay, whereby each of the array element is actually a key for the dictionary, and the value is the count. the number of occurrences of that key in the original array. Okay. Now, after that, all you need to do is to go through this dictionary, all right, to check any of the values is odd. So again, you have an odd count here that you initialize to 0. And as you go through each of the key in the dictionary, you just check the corresponding value. Is there any one of them that is odd? And just increment this counter. And after that, at the end, all you need to do is to check this counter. Are there more than one keys that have odd counts? If that is the case, that means this input array cannot have an arrangement that is palindromic. So you will return false. Otherwise, you will return true. Okay. This is the rubrics for question 5. If you have attempted this question by approach 1, sorting the array is 1 mark. Then the counting for the frequencies of each group of consecutive elements is 2 marks. For this part, some of you have not been very clear as to how it is done to achieve big O of n complexity. So marks are deducted due to that. Finally, based on the number of odd frequencies, the correct conclusion is drawn, is 2 marks. Some of you have this part ties together with the loop in the previous part. Well, so long as the whole thing makes the algorithm works fine and come up with the correct conclusion, you will be awarded the full 4 marks. If you have attempted this question by the second approach, then the creating of the dictionary is 2 marks. And going through the dictionary to determine how many elements have odd number of occurrences is 2 marks. And the final conclusion based on checking the number of odd occurrence is 1 mark. So a total of 5 marks for this question.